All right, guys, this lesson is on centers of triangle. Specifically, we're going to focus on the circumcenter and the incenter. So first page, we'll talk about the circumcenter, and the second page, we'll talk about the incenter. And the last two pages kind of mixed practice where we'll kind of hammer some of the stuff out. One thing you do have to use on this a lot is Pythagorean theorem. So if you need to brush up on Pythagorean theorem, maybe kind of just Google that or look that over again. But I'll do a few Pythagorean theorems as we go through the problems today. All right, circumcenter first, guys. The perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. So if you guys check out the triangle, guys, these are your perpendicular bisectors. Remember, they cut a side in half, and they intersect at a 90. So you have PE is a perpendicular, PF is one, and PD is one as well. All right. Next bullet, their circumcenter is always equidistant from the vertices of the triangle. All right, so what that means is this, guys. These pieces, here's your vertices, A, B, and C are your vertices. They're equidistant. So that means these, let's put 4 lines on them, are all the same, okay? So AP, BP, and CP are all the same distance. All right, so let's check out the diagram here. It says use diagram to the left to answer the following questions. List the perpendicular bisectors. Okay, well, it's these 3 pieces right here. It's PE, PD, and PF. Name the circumcenter. That's your center point, guys. Your circumcenter is point P, or just P. List all the congruent segments. All right, we got a lot of them. Let's start with the vertices to the center P. So we have AP, which is congruent to BP, which is congruent to CP. Next, then we can do the sides. Remember, the perpendicular bisectors cut your sides in half. So BE and EC are congruent. Bottom piece, AF and FC. And the last two, AD and DB. AD congruent to DB. So those are all of your little congruent pieces when we're talking about the circumcenter. So the practice, we get to find some missing pieces using these properties right here. So a lot of Pythagorean theorem. All right, number 1. All right, it says if Z is your circumcenter of triangle TUV, find each missing measure. So first, before I even look at these, I'm going to try to fill in some pieces on my own. I know I've got, these are all 90s, so just remind myself, I throw in my 90s. And the sides are all cut in half. So if that side's 19, that's 19. If this whole thing is 34, cut that in half. Each of those have to be 17. That's about all I can do right now. The other pieces are going to require Pythagorean theorem. So let's see if we can answer the questions now, though. TU. Oh, we got that. T to U, 1919. That's 38. V to Y. Oh, we just did that one. That's 17. U to Z. All right, so now we can use Pythagorean theorem. Right? So we're trying to find this piece right here, right? So if we're looking at this guy, we know that all three of these pieces on the inside from vertice to center are all congruent, right? So if I look for that, if this guy is 21, this guy and this guy all have to be 21 as well. So he's 21 and he's 21. So U to Z, 21. All right, Pythagorean theorem time for letter D. W to V. W to V is right here. All right, this piece right here is what I'm trying to find. I can use Pythagorean theorem. A squared, remember here's my 90, these are the legs. A squared plus B squared equals C squared. So I'll call this piece just X or something, right? So there's your triangle right there. Pythagorean theorem. 15 squared plus X squared equals 21 squared. Subtract the 15 squared over. That'll give you 216. Square root 216 comes out to be 14.7. So from W to V, 14.7. So 14.7. That guy's 14.7. Here's why I did that. They want the distance from T to V. So 14.7 plus 14.7 comes out to be 29.4. So when you guys do this, the quickest way is fill in all the pieces that you know, and then you're going to use Pythagorean theorem to find any missing pieces, okay? So number 2, once again, try to fill in all the missing pieces. H is your circumcenter of triangle BCD. Find each missing measure. All right. Whole thing's 24. Well, first put in your 90s. Don't forget your 90s. Cut that 24 in half. 12, 12. The vertices to centers at 13. Remember, all your vertices to centers at 13. So this guy would be 13. This guy would be 13. If this piece is 7 right here, this piece has to be 7. And I believe that's all I can fill in right now. All right, questions. G to D, just did that, 12. B to C, the whole thing, 7 and 7, 14. E to H, that is right here. We are going to have to use Pythagorean theorem, right? So for letter C, Pythagorean theorem. If I kind of cover this up for you, there's my triangle kind of right there, right? I can use Pythagorean theorem to find that distance. So E to H, I'll just call it X for right now so we can do it. Either way, A squared plus B squared equals C squared. So X squared plus 7 squared equals 13 squared. Subtract the 7 squared over. That comes out to be 120. Square root 120. That comes out to be rounding to 11. Rounds up to 11, we'll call it. So E to H, that's 11. Letter D, how far is it from F to D? Well, once again, Pythagorean theorem, guys. Right there, make a little triangle. We'll call this little piece X. A squared plus B squared equals C squared. So this is letter D. All right, X squared plus 3 squared equals 13 squared. Subtract the 3 squared over. That gives me 160. Then I got square root the 160. That comes out to be 12.6. So F to D, 12.6. C to D, well, that's the whole thing, right? Well, if that's 12.6, I know this is 12.6. Just add them up. That comes out to be 25.2. Number 3. All right, it says if M is a circumcenter of GHI, find each missing measure. All right, fill in pieces. 31, 31. 30, 30. Can't do that side. Do we know any of the vertices to center? Nope, we don't have any of those. Okay, so here we go. But we're going to use Pythagorean theorem for this one. First one, G to I. G to I, this whole thing, 30 and 30, 60. M to H, this piece right here, we do not know. Forgot my 90s. All right, Pythagorean theorem, guys, right there. There's your triangle. We'll call this piece X. I'm sorry, M to H we got to find. My bad, right there. Here's your triangle right there. All right. A squared plus B squared equals C squared. So for letter B, 14 squared plus 31 squared equals your hypotenuse squared, and we called it X. If you add up the left side, that comes out to be 1,157. Square root that. X comes out to be 34. So M to H, we know, is 34. So now all of the vertices to the center are going to be 34. So this guy is 34. That guy is 34. Vertices to centers are all the same. They're all congruent, all 34. M to H, 34. I to K, right here, the Pythagorean theorem. All right. We could do this triangle right here if you wanted to. All right. So for letter C, we're trying to figure out I to K, call that X. A squared plus B squared equals C squared. So 23 squared plus X squared equals 34 squared. Subtract your 23 squared over. X squared comes to be 627. 627. Square root that. That comes out to be 25. So from I to K is 25, which means K to H is also 25, right? So how far is it from H to I then? Well, 25 plus 25, 50. Last one, M to G. Hey, we already filled that in, right? All of your vertices to center points are all congruent. So that guy's also 34. All right. That's good for circumcenter. Let's check out the old incenter now. So I'll mark this guy up, and then we'll knock out some examples down here for 1, 2, and 3. Once again, Pythagorean theorem for sure. All right, first bullet, the angle bisectors of the angles of a triangle intersect at a point called the incenter. So this guy right here, point P, that is your incenter. All right, the incenter is always equidistant from the sides of the triangle, which means this. All of these pieces from the side are all equidistant. So what I'm going to do is I'm just going to put a little mark in there for you. Those guys are all congruent. So before, for the circumcenter, these pieces were congruent. But for incenter, it's these pieces from the side that are congruent, not the vertice. All right, and we have some more congruent pieces too. Angle bisectors. So remember, guys, when you cut an angle in half, it's right here. Your angle bisector cuts the angle in half. And however, this does something else. It creates two congruent sides over here as well. Angle C bisector, those guys are congruent. And same thing for the bisection of angle A. Those two pieces are congruent. So as long as you guys have your diagrams marked up pretty right here, I think we can fill in a lot of these pieces pretty quick over here. So first one, list the angle bisectors. Well, PB is one. CP is another one. And the last one is PA. Name the incenter. Well, point B. Now list all the congruent segments. Well, we're going to list them, but you can see it right over here, all of them. So we'll start with the incenter ones. We get PD, PE, and PF. So PD is congruent to PE. And the last one is PF. Comma, and we'll take care of all the angle bisector ones. Start up top. DB, BE. Over at C, we got CE and CF. And the last one, AF, AD. All right, let's go to work. All right, it says if P is the incenter of triangle JKL, find each missing measure. So once again, let's try to fill in all the pieces that we know here, right? All right. Sides to center are all congruent. So if that's 8, that guy's 8, that guy's 8. Let's see here. We know that, remember, it's kind of mark it, guys. If this is the angle bisector, go ahead. Remember, these angles are all congruent. They're all cut in half, right? So if this side's 17 over here, this side is 17. And I believe that's all we can do. We don't know either of these. We don't know either of those. And we got the centers filled in. All right, here we go. We can go to work now. First one, N to P. Oh, we got that already. That's 8. N to K. Yeah, we do that one. That's 17. P to K. Oh, Pythagorean theorem, right? There's my triangle right there. P to K we got to find. Let's just call that X. A squared, B squared, C squared. All right, so for letter C, let's do 8 squared plus 17 squared is X squared. Left side adds up to be 353. Square root that. That comes out to be 18.8. So from P to K, that's 18.8. Letter D wants L to O. L to O is right here. Well, once again, Pythagorean theorem. See it right there? We'll call L to O X, right? A squared, B squared, C squared. All right, so we're going to have, this is letter D. We have 8 squared plus X squared I'm thinking, all right, equals 13 squared. There we go. Sorry. Lost it for a second there. Subtract over the 8 squared, so 13 squared. 13 squared minus 8 squared. That comes out to be 105. So x squared equals 105. Square root that. Let's see, that comes out to be square root of 105, 10.2. So from L to O is 10.2. Lots of Pythagorean theorem, guys. You'll be masters at the end of this lesson. Number 2, fill in some pieces if you can here. All right, let's fill in the angle bisectors. Okay, if this side's 35, this side's 35. If this side is 6, that side is 6. Nothing down here, and I don't have any of these pieces right here, right? I don't have any of the in-center distances there, so I filled in what I could. A lot of Pythagorean theorem once again. G to D for letter A. G to D, nothing. But there's my triangle right there, right? I can use Pythagorean theorem to figure out that guy. So we'll just call this guy X, right? A squared, B squared, C squared. So for letter A, X squared plus 35 squared equals 37 squared. First step, subtract 35 squared over. That comes out to be 144. That comes out nice. When you square root 144, it comes out to be 12. So all of these center pieces are all going to be 12. 12, 12, 12. Next one, B to G. B to G is right here. Man, once again, Pythagorean theorem, right? Kind of covered up there. There's your triangle right there. A squared, B squared equals this piece right here, C squared. So for letter B, we have 6 squared plus 12 squared equals, call it X squared. Left side adds it to be 180. Then we square root that. Square root 180 is 13.4. So from B to G right here, 13.4. Next one, F to C. We did that, 35. B to F. There it is. We did that already. That was 6. All right. Number 3. All right. It says S is the incenter. All right. So hang on. Do our angle bisectors. Okay, then we got some stuff here. We have angle PRQ, PRQ. So all of this angle right here is 8x minus 10. Angle RPQ, RPQ. So all of this is 4x minus 14. Angle PQR, PQR. So all of this is 7x minus 5. Let's just find each missing measure. Okay, we can do this. First one I want is angle PRQ. All right, well, we have a triangle. And we know that if I add up all three angles of a triangle, it has to add up to 180. So what I'm going to do is I'm going to combine all three of these terms and equal it to 180. So if I add up all my x's, I got 4x, 8x, 7x. That's 19x. Negative 14, negative 5, negative 10, negative 29 equals 180. All three angles add up to 180. Add 29 over. That gives me 209. Divide by 19. X is 11. So now just plug 11 back into all of these, and then we get our degrees, right? All right, so this guy comes out to be 78. This guy comes out to be 72 when you plug in 11. Plug in 11 over here, that comes out to be 30. If you add up all three angles, it adds up to 180 degrees. Okay, first one's PRQ, 78. RPQ, RPQ, 30. PQR, 72. RPS, RPS, this piece right here. Well, if the whole thing is 30, half of that has to be 15. PQS, PQS, this piece, well, the whole thing is 72. Cut that in half, 36. Angle PRS, PRS right here. Half of 78, 39. And last one, PSR. All right. Triangle, right? Once again, all three angles have to add up to 180. So you got 15 of it here, 39 of it here. What's left for that guy right there? Well, just take 180 minus the 15 minus 39. That will leave you with 126. All right. That's good for the incenter. All right. This is a long assignment, so what I'm going to do this, guys. I am going to go through these on the next 2 pages just to make sure we understand the properties. And then if you want to, you can skip this part, but I'm actually going to go through this as well too. But if you just want to check out the answer key as I go through these ones, that's fine too. But I will go through these ones in the notes for you guys. All right. Circumcenter and incenter. If W is the circumcenter, all right, time out. Circumcenter means those three pieces are congruent, right? And then I know my 90s are right here, and the sides are congruent, right? So if that's 19, that's 19. If that's 21, that's 21. The whole thing is 32. Cut it in half, 16, 16. Middle pieces are all 24. Okay, let's see here. R to S. R to S, whole thing, 38. T to Q, 16. W to S, 24. Q to V, 21. T to W, where's T at? No, Pythagorean theorem, right? A squared plus B squared equals C squared. I'll set it up, but I'm just going to give you guys the answer. X squared plus 16 squared equals 24 squared. Comes out to be 17.9. W to V, the little piece right here, right? A squared plus B squared equals C squared. 21 squared plus X squared is 24 squared. Answer comes out to be 11.6. All right. Bottom piece, these will go kind of fast. Just got to make sure you know the properties. Find BC. Okay, well, we know the sides get cut in half, right? Set them equal, solve for X. 13x minus 51 is 10x minus 33. That's the setup, and I will give you the answer. X is 6, but then you got to plug it back in, right? Plug it back into both, add them up, 11.6. Number 8, your job is to find AP. Well, we know that all of those pieces are congruent, right? So just set these guys equal to each other, solve for X, and plug it back into either one because these are all the same distance. Setup, 11x minus 14 is 6x plus 1. Solve it, it comes out to be 3. Now you can plug it back into either one of these because all three pieces are congruent. Does not matter which one you plug it into. Solution comes out to be 54. Number 9, find D to P. So we got to find this piece right here. All right, let's see here. I know those two pieces are congruent. So first thing I got to do is I got to solve for X. So set up 8x minus 52 equals 2x plus 14. Solve it. X comes out to be 11. But my job is to find DP, this piece right here. Okay, we can do this. I know if this is 39, this is 39, and that's 39, right? But I got to use some Pythagorean theorem here. So first I can take my 11. I can plug it back into either one of these, and then I can set up Pythagorean theorem, okay? So if I plug, say, 11 in right there, that comes out to be 36. Now I can do Pythagorean theorem, right? Check this out. A squared plus B squared equals C squared. So set up X squared plus 36 squared equals 39 squared. If you solve that out, it comes out to be 15. That is your solution. Number 10, our job is to find FC. Where is it at? So we got to find this piece right here, right? All right, we got some work to do here. Let's see. I know all of my vertices and centers are all congruent. So what I can do is I can set these two guys equal to each other and solve for X. So 5x minus 16 is 3x plus 2. I solve it out, it comes out to be 9. Okay, I need this piece to figure out FC, right? So I can plug it back into either one of these and get this piece right here. So let's just say I plug it back in right here, right? That's going to come out to be 29. So this guy is 29, he's 29, and then he's 29, right? There's your 90 Pythagorean theorem. A squared plus B squared equals C squared. 14 squared plus X squared is 29 squared. Subtract the 14 squared over square root. Solution comes out to be 25.4. All right, last page. All right, incenter, right? So remember for incenter, these guys are congruent, right? So 13 and 13. Your angles get cut in half. So if that's 28, he's 28. If this guy's 24, that side's 24 up top. If that's 30, this is 30. If that's 39, that's 39. And I believe that's all I can do right now. All right, here we go. Angle MJP. MJP right here, 39. JKL, JKL. All of this, right? Okay, we can do this. 28 and 28, 56. 39, 39, 78. There's 180 inside of a triangle. So if I add these two up and I subtract from 180, angle K is going to come out to be 46 degrees. So this whole thing is 46. Cut that in half. 23 for that guy. 23 for that guy. Next up, angle NKP. Where's it? NKP. Oh, we just did it. 23. KLJ. KL. Oops, sorry. KLJ. The whole thing. 56. N to P. N to P right here. 13. K to M. K to M right here. 30. KP. Pythagorean theorem. So how far is it from here to here, right? Well, A squared plus B squared equals this piece C squared. So set up and then I'll give you the answer. 13 squared plus 30 squared equals X squared, we'll call it. Solve it out. 32.7. P to L. This piece right here. Well, once again, guys, Pythagorean theorem. A squared plus B squared equals C squared. So 13 squared plus 24 squared equals X squared. Solve it out. Comes out to be 27.3. All right, 3 more. P is the incenter. So remember, those guys are congruent. Angles get cut in half. Find X. All right, we got some work here. We got to figure, well, what degree is this, right? Well, we can do this one. If I'm looking at these angles, 27, 27, 19, 19, right? This whole measurement over here would be 54. 19, 19 is 38. All right, so if I take 180, I subtract these two guys right here. So if I take 180 minus 38 minus 54, this whole angle up here is 88. But it's only pointing to half of it, right? So half of 88 is 44 degrees. So simply, I just got to set this guy equal to 44 and solve. 17x minus 7 is 44. Add the 7 over. Gives me 51. 17 goes in there 3 times. Next up, K to I. So real quick, just remember, all these pieces are congruent. So K to I is the same, right? So once I solve for X, let's plug it back into one of these guys. And I got K to I's distance. So equation, 3x plus 17 equals 7x minus 31. Solve it out. X comes out to be 12. Now you can plug it back into either one because they're all congruent, right? Doesn't matter which one you plug it back into. Plug it back into that guy, that comes out to be 53 per length. Last one. Let's see here. We got to find D to K. We got to find this piece right here, right? All right. Well, remember, these are angle bisectors that cut the angles in half. These two sides are congruent. So what I can do is I can solve for X. And then I know, well, let's do this first. Pythagorean theorem's coming up. So first solve for X. So 9x minus 16 equals 4x plus 9. Solve it out. X comes out to be 5. All right. All these pieces in the center are 18. So that's 18. That's 18. That's 18, right? Well, Pythagorean theorem, guys, there's a triangle right there. Take that 5, plug it in here so we get some distance. If you plug it in there, let's see here, that'd be 4 times 5 is 20, 29. A squared plus B squared equals C squared. So 18 squared plus 29 squared equals X squared. Yada, yada, yada. Solve it out. 34.1. All right, that is it for incenter and your circumcenters.